Thank you.
Oh, it's cool. It's cool. So, bad translation, because a picture says more than 1,000 words is translated from a Chinese proverb that says you can hear it 100 times, and but sometimes that is not necessarily better than just seeing it actually once. So I'm hoping to show you today in this session a little bit about fact-oriented modeling, which is hopefully a little better than just seeing a picture and trying to make up what it is. So we'll go to the next slide. The fact-oriented modeling rooted all the way back, I think, somewhere in the 50s, where they started doing structuring on data on a very constrained set of memory and storage, etc., etc. And the Dutch started figuring out, this needs to be tied into language, and if we can write and talk about it, then we might be able to derive a better structuring of data. And in the 90s, this fact-oriented method came that's called FCOM, and I'm going to talk about that a little bit more. FCOM stands for Fully Communication-Oriented Information Modeling. That's a big word right there. So what we find in IT commonly is that there's this lost in translation somewhere where the people in the business do their work and they need an IT system, and there comes this IT specialist that tries to understand what they're really doing and what they need, starts drawing pictures, and as we saw, that could be a risk, and uses that as specification to build and implement systems, hoping that it will service the business in a way that they need for their own communication. And that's where a lot of translation happens, and sometimes that goes wrong. And at the same time, by building system after system, we may end up with many silos. And in the last few decades, we created this new problem called BI, because now we need to have some management report which covers all systems in the organization to be of anything meaningful. But we kind of lost track what was in every source system and implemented system in the first place, because we did abstractions and pictures, etc. So in all of that, we are going back to, okay, who is using this source system? What is actually in that source system? Where is the data? When is the data there? And even questions like why? And down the road, it becomes a question. Okay, we built this map, but how to actually reach the final destination in a meaningful way? And on top of that, and we see that nowadays more and more, data really affects lives. It's not just the data that's in a database anymore. Systems report personal data. Systems affect lives, like this picture shows you. It's like as soon as you do something with data or IT systems, then the question becomes more prevalent. That is, are you sure that this is the right way to do this and the correct way to handle it? And the only real way to tackle that dilemma is to realize that we're working with data which is from our experts, and it is for the experts, and therefore we also should do it with the experts. And in IT, we created something that's rather complicated, like UML class diagrams. We created logical diagrams, conceptual, logical, physical, but none of that really communicates with non-IT staff like people in the business. So I'm clearly stating that we shouldn't just do IT. We really shouldn't. If we're involved with data, we should really try to give it a different approach to connect back to the business. But I must warn you, there is no magic potion in that. Even though I promote this fact-oriented modeling method, still work needs to be done. And the difficulty comes in place where, there's data all across the supply chain in our organization, and it seems to shift in organization, but at the same time, it never really should lose its meaning. And the way that we want to make sure that it doesn't is we try to, with fact-oriented modeling, we try to capture the communication. Real communication between people, of course, redacted in a certain way, but we try to capture that communication in a way that it preserves what is being said, it preserves the examples that are encountered, it preserves the meaning, the definition, the verbs, and all of that. And with that, we generate pictures of UML, logical, physical, and to better align IT systems with the original communication, which increases the chances that those systems really are supporting the communication that the business has in the first place. And that goes through a couple of cycles. If we start here at the top, we have John speaks with Mary in natural language, but we need to formalize that language a little bit to be able to then extract fact statements. And we talked a little bit about that. I'm not going into the topic of alternate facts. Let's just go with the facts, as in, if I make a statement and we both agree, then we consider that to be a fact. And from that, we can drill further down. We can do the model-to-model transformations, generate the artifacts, build the implemented systems, and then we're back to square one. However, it's not just John communicating with Mary, but there is a computer in between that also supports that communication. And by going through this process of capturing communication, formalizing it, and structuring it, etc., we find that we may develop a shared common knowledge in the organization. And across domains, there might be some shared domain knowledge between two departments that work with the same data. And there can be departments that are a little bit outside and specialized in the organization that have very domain-specific language. And mapping all of that helps to standardize the language in the organization, and it helps aligning different systems towards this common language. Now, this is all about the approach. Let's slowly go into this fact-oriented modeling, and I would like you to look at it slightly differently. We're not going to talk about tables, entity, classes, so we're not going to look at data in this form. We're not going to look at data as in a technical format, we're not going to figure out how to design XML or how to build JSON files or API specifications. No, we're really going to look at the relationships, which are the building blocks themselves. And once we have done that, this modeling part of these building blocks, then we can generate the tables and entity classes. We can generate all the artifacts that we need. So this is a different way of looking at data. This slide basically shows in a nutshell what it is about. With the domain experts, we basically verbalize facts in natural language with concrete examples. You can recognize here that it doesn't have any type level language in there. It's not, employee had a checkup on a patient. No, it has a real concrete example with it. Because as soon as we start saying employee, then everybody says, yeah, okay, well, he was a hired employee and this was a consultant, and how do I identify this one and what is the distinction? As soon as we actually concretely give an example with that, a lot of that nebulous talk on type level is becoming obsolete. And on the bottom left, you will see how a fact statement, like given above, is full of detailed information. And it's basically doing similar things at the elementary school. What is the subject? What is the topic of it? What's the verb? It follows similar ideas. And then we can depict that in graphical diagrams. And from these diagrams, we can then generate back these expressions. So the business users that provide all the fact statements doesn't necessarily need to validate the model. It can just read back a textual report coming out of the models. And in regards to model generation, as soon as we have the business requirements given in example facts, we have this conceptually elementary model. And with the tools, we can then just perform grouping and reducing and lexicalizing. I will get back to that in a bit. And then depending on which transformations we apply, we can then generate the UML class diagram or an entity relation diagram or a relational model, or even further transform it in preparation of dimensional models. And it shows that if we did this, we don't also need to build a UML class diagram. We don't also need to build any of the other models. We can simply generate that from. This is a small example. Part of this model is called the checkup, and from that, if we can generate the DDL for database statements, we can generate the XML schema definition files for that, and they all have the same terminology. So I'm going to take you along with a small example use case. This photo came from an event that I found on the internet where a person, after a weekend at home, goes back to the office on Monday morning and the car starts smelling a little funny. So she calls AA to get support for the car. Mechanic comes by, opens the hood and sees this stash that apparently the squirrels put up for the winter. So, they cleaned the car was driving fine, no problem, but it was a funny anecdote. And I kind of used that. I used that to come up with a little story that said, well, John has this car and he's got problems with it, and he calls and there's a ticket being opened for this specific car. And but Lisa picks up the phone, doesn't know how to handle it, so she escalates the ticket, and then Ronald, the manager, authorizes the ticket. This ticket then is assigned to mechanic Jack, and Jack provides support for this ticket 99. Just very simple but concrete steps on what's happening in this business process. So first what we do is we type out all these expressions after having found them and talked with the domain expert. And then we classify each fact statement according to a specific type. So the driver John owns vehicle 22BZTV is a statement that expresses the driver vehicle. So every fact is then classified according to a specific type. So let's look at the first one. We have, on a higher level, driver owns this vehicle. And we drill down a little and it says, well, driver is actually communicated through driver regarding a person. And the vehicle is communicated as vehicle with a license plate. And again, we drill down, the license plate is filled in, and then the person is identified by this person name. And remember, this is a small example. We have a small business case, so all our people are defined by their unique name in our small world example. And this person name is John. Now we want to make that a graphical representation because in IT we love diagrams. And basically it has all the information right there. It has at the bottom in green, you can see parts of the expressions coming back. It has little boxes with numbers which tell you how to substitute the expression to come back with the original statement. It comes with examples that says John, license plate. And then as soon as we did that, we can enter the next expression. So let's add support request. Again, there's a rich information structure. And there's something interesting going on because we add the support request, but the entire branch of the expression below the driver, we already had that in our information model. So with the tooling, it will then start recognizing previous examples, previous patterns of expressions. So the diagram is just not duplicated, it just adds on. And I'm going to scroll to the ticket vehicle, and you can see how every expression has structure. And adding those graphically is simply a matter of dragging another information element in a diagram, and it will automatically draw all of that for you. So I'm going to go through all of those, and then after having done the last one where Jack finally handled this ticket, you will see a conceptual information model just from 7 statements. And with that, we can, as I promised you, we can transform this entire structure in a way that resembles a relational diagram. And here you see the tables coming out of that. You see the relationships, the one-to-many, the optional roles, the primary keys. But interestingly enough, it also has the communication still on board. On type level, on substituted to columns, person authorizes support for request ticket number. And underneath that, immediately the full expression with the concrete examples. And this shows that if you can generate this and maintain the communication, then the business user is far more able to actually validate what this diagram shows. But then again, we have the software developers, they need something else because they organize their classes in different ways. And UML class diagrams can be evenly complicated, but come out in a controlled, unique manner as well. And again, 7 statements also provides for this. More interestingly, for people who really like data, we can also generate all the DDL, the database, etc. And on top of that, provide database views that will make the communication that went in resurface to application developers and report generators. It contains the primary key for tickets, and then it has all the verbalizations that are connected to that core business concepts. Now, as with many things, how do we know that we did it the right way? There are ways to validate this process. Validation in that respect is sometimes a little tricky. So let's see what's happening here. I have this employee 465 that's performed a checkup for patient 123499 on 12th of 10th of 2019 at 4 o'clock. Now, how do you start validating this? Where are the business rules hidden in here? Let's just add a couple of examples. And we're going to present these as if we were talking to the business to figure out, okay, where are the unicity constraints, for instance? And the first population says, employee 465 performed checkup on apparently 2 different patients at 2 different times. Can that occur? And domain experts would probably say, yeah, that's fine. And then the second one, it presents 2 different employees for a checkup on the same patient at the same time, where the boss says, no, I won't allow that. There's only 1 employee doing a checkup, which would then place constraints on the information model, leading to a simple table. For every checkup, there is 1 employee ID. Fine. Let's go down and say, well, the second one can actually occur too, because, I could have an internship that is just learning how to do the job. He'll be there with the same checkup, which requires me to structure the database in a different way. Now note, the business is giving me explicit guidance on this, and the constraints on the information model are then applied differently, which would then lead to an entirely different logical model. So there are a couple of variations there, which all lead to different outcomes in database design, but they all start with simple questions and answered by the business expert. And I won't go through this slide. There is a ton of automated validation rules to check if you didn't leave anything in there that might be redundant or simply false or missing, etc., etc. So there's a huge list of automated checks for your information model. And once that is done, you might want to present it back to the business experts to have your paragraph there that that you did a good job, and he would agree with it, and then you can move on, build your IT products, etc. So with the information model, there needs to be some sort of reporting back in a way that the domain users can actually validate, but also at the same time register with every information element that goes into this model, who was the interviewer, who was the department, who was the expert, etc., etc. So all of that can be done on a language level that is beyond the scope of many other modeling tools. So I'm going to go through a simple model-to-model transformation, so you at least get an idea on how that would work. And of course, tools do this for you, but just for your insight and for the fun of it. I have two statements. Patient 123499 has family name Smith, and patient 12349 is born in Utrecht, the city where I currently live. There's this little information model, and we're going to go through that in 3 transformational steps. Let's group some of the information elements here. Starting at role number 4, it has the example population 123499, which also is under role 3 with patient, which is also the same as under role 20. So what we're doing in the first step is we're grouping patient surname and city of birth into the patient. Let's see what happens there. The diagram changes slightly, yet the communication is still intact. The communication did not change. We simply grouped some of the relations into one. Then the next step would be to lexicalize it. Imagine that if you have a database table, that every column needs to have a type definition for its data type, which means that role 21 cannot go through something else first. It needs to end up with a data type, which is the city name. Therefore, we're drawing a line from 21 to city name, and we're cutting the line that runs to city. Just another step. And then the last step is to actually start reducing stuff that is becoming obsolete after these model-to-model transformations. And since we started with communication about data, and we maintain the communication of our data, we now notice that the city itself doesn't need any verbalization anymore, because the entire population for city is now completely captured under role 21, including the expressions. So we can cross off the city. And then we would end up with a simple table, and we'll use that to generate our artifacts. And as you can see here, we end up with 3 data types: city name, family name, patient number, and we can then generate our create table statement. And in the comments, we actually have the original type level expression, so that even the DBA can actually see, okay, wait a minute, we're working with a database here, and this is how it's being used by the business. And nicely, we provided examples. So we can, after creating the database, we can do the load script and insert all the examples that were given by the business. And we can do a little more, because we have all the expressions. We can also create those views on top of these tables, as I've shown earlier. There's a simple create view statement that generates all that for you. And once you select the table and join it with the view, you get all the data and all the expressions. Well, no surprise, a relational diagram that has all the verbiage in there. It is accompanied with a UML class diagram that can be visualized out of that. And for the C-level management, we can still do this concept map-like diagrams that says, well, I have this patient and I have a checkup and an employee and a date time. And it's a really condensed way of displaying all the rich information that we had. Now, I'm not quite sure what my audience is in here, but there's a lot going on semantic web. You can understand that we can generate all the RDF OWL specifications out of this just as easily. Just again, it's a different structure. And this is a visualization of it. the XML schema definition files. I've shown this picture before, but you may recognize it a little more. JSON schema files, if you're doing API development, making sure that all the comments with all the objects in the JSON file contain, again, the pre-formatted text for data substitution, so that even on APIs we can still read and understand what that data being transported over the API actually is representing in communication. And I'm rather excited about the next slide. That is, even we from the tool we generate VB scripts that can be run in Power Designer or ER Studio, and it will out of the blue generate this entire logical model, nicely named with examples, descriptions in the comment fields. All of that is being passed on to the tool. So this doesn't need to be drawn by hand, because all of this is being validated before it actually starts here. And there's a large list of other DBMSs that we support, and tools and formats. I would like to take you even deeper. If you're not overwhelmed yet, let's go deeper. We're going to show you a little bit about language variants, different ways of verbalizing facts which actually express the same thing. This simple example, patient 123499 is called John, or John has patient number 123499. They both express patient first name. And this is just an illustration. It can be a combination of Dutch, English, French, whatever. They still maintain the same information grammar and lead to the same information grammar diagram. Very interesting if you're working for companies that do local and international business. Semantic equivalence also, I state the same fact, but I structure it differently depending on the business needs. In the first expression, the diastolic pressure is a static, but in the second one, we make diastolic pressure something that can be changed because the business might require it to be diastolic or systolic. So instead of modeling it static in structure, we can also make it dynamic and configurable in the second option. All different approaches that do not change the language, interestingly enough, but it's all a matter of what kind of knowledge do I put in the structure that is underlying these fact expressions. Another great example, there's a ton of discussion out there. In IT, we sometimes encounter data models that have party or customer. And then if you go back to the business and it's like, okay, what is this party or what is this customer? You will end up in a very weird place where everybody has a different definition for customer. So what we try to do is focus on facts, not just on the concept itself. And this illustrates that. We asked the help desk and they said, we have a customer ticket. We asked sales and they say, well, we have a customer contact moment. So nobody really talks about the customer itself, but we can use this to start building information models. And once we move that into a diagram to visualize it, you see that there is something called customer. But depending on the context that is connected to it, it has different identifiers, which is intriguing. So now we see that customer can have multiple implementations across the organization. And of course, that needs to be mitigated in our production, but we can start defining it. Again, another advanced example, we have this company protocol. There are all kinds of parameters. We state that every employee has at least 22 vacation days, and there's a lot of age, employment years, and the outcome of vacation days that goes with that. So what I propose here is we start writing down this matrix with all the conditions and outcomes. On top, you see all the conditions, the age of the employee, the employment years in different ranges. And then at the bottom, we have all the outcomes that says, 22 vacation days, 5 extra days, 2 extra days, all from this policy. And we fill in the axes, which outcomes are applicable under which conditions. So the next step is we cross off whatever is not relevant. We then merge all the cells that are the same. And as you can see, every condition leads to 22 vacation days. And only if you're over 60, then you get 5 days extra there and 3 days extra there. If you're over 30, so etc. You can see, and now the interesting part is, what do these axes communicate? So we sit down with the business again, and we let the business do their talking. Let them state facts. And for every X, there's a fact statement done by the business. 22 vacation days, says employees receive 22 vacation days. Fact. Everybody agrees. And so we go through that list. Now, to make sure that we test it, we also talk to HR. We come up with 2 lists of fact expressions. On the right, which is the verbalization of our matrix. On the left, we just found some interesting employees in our database that meet the various requirements. And then we start modeling it. So what happens is we end up with an information diagram. On the right side of it, it has all the structure in place to surface our requirements. On the left, it has employee and the total employee vacation days. That is the outcome of this calculation. And what happens now is that as soon as we generate this database, you can see that the employee table is coming from an HR database, and all the others are there to configure the steering parameters depending on the current state of regulations for vacation days. And then the software can use these tables as configuration data so that all the requirements and conditions do not have to be hard-coded anymore in the software. And, of course, there needs to be software. So this is how the classes can be built to actually surface all that logic. I'm sure there is someone who does data warehousing or data vault. And we're working with the people from Genesee Academy to integrate some of their ideas with our tools. And this is a little study done in advance of data vault integration. We have this information grammar, and it's very close to what Data Vault tries to do with core business concepts. One of the first things that we can do is recognize where are the hubs, which are typically all the object types that have communication, which is relevant, and are readily available right there. And they came from the communication, from stating facts with the business. We discover what the object types / core business concepts are, and which could lead to the hubs. Next phase, anything between hubs needs to be a link. And I'm just color coding it. I'm not actually generating a different diagram yet. I'm just trying to give you some visual insight. And then we have a lot of related fact types that then form satellites. And these can be steered. We're still working on that, but we already started doing some model-to-model transformation that extract this data vault definition straight out of an information model. And the beauty of it is that where ensemble modeling goes top-down, we sit at the whiteboard, start defining terminology. This fact-oriented modeling approach is bottom-up, and it has very well-grounded examples, very accurate communication, sort of ties in with the business in a very close and high-quality manner. So I'm going to close up this presentation by just finishing up with some slides. It's a great joy to see that the method of FCOM is now, and the fact-oriented modeling methods are now mentioned in DEMBOK 2. There's just one small note. The paragraph 1.3.4.4.2 on fully communication-oriented modeling is not the best article in the book. There's a lot of mistakes there. It was written and published in mysterious ways, and I'm actually talking with Damar to have that amended in the new version of Dembok that comes out. Because the examples, the diagrams, you know, it's all off. So keep that in mind if you try to look it up. This methodology is being applied in large enterprises, big organizations that have tons and tons of data domains that all need to be aligned to each other. So if you're in an organization with high quality requirements for the model, try to look into fact-oriented modeling. If your domain is complicated and even, you know, privacy issues can be complicated already. If you're doing cargo, logistics, or chemistry, or hospitals, those domains can be pretty complicated. And then having to sit down with a domain expert, having a structured method to actually go through this information gathering can be very rewarding. Also, when you have an environment where there's a huge amount of data types, high type volumes, then this can be very helpful because it supports you in going through all of that very systematic. Again, data governance, it sounds like a given, but try to do that on a column-based method in any logical model. That's a pain to administer. And fact-oriented modeling does that out of the box for you. And instead of modeling every new technique out there, just try for once, do it in information modeling and then generating it. You'd be surprised to see what can happen. And of course, you know, there are books out there, but there is also a tool which I'm responsible for. It's called CaseTalk. It's just a screen print on all these different details that you might want to build. It comes with a viewer to simply use drag and drop from the central repository to come up with different diagrams and visualizations. We provide version management, impact analysis, difference report, multi-user, all of that on all of those models. And just recently we came out with a portal, and specifically the data governance people will appreciate that, is whatever version of model was in there, it comes out, it's registered in a database, and everything is browsable, searchable. And you can actually see the lineage of every fact expression throughout all the data domains. Just as a small clarification, the method of FCOM was developed in the Dutch by math teachers at universities, and they always had this condition on the table that said, you know, this needs to be available to education. So even today, 18 years after we started this, we still have a free educational edition for schools and universities. Look it up if you need it, or at your university, or if you're teaching to your students. It's great educational material because it's so well structured and methodology method. How do I put that in English? Procedural methodology. And specifically for the people in South Africa, we are very aware that software comes at a very steep price, either in US dollars or in euros. And on our website, we offer something called equivalency, which is measured in an average working hour rate. So if you're actually interested in what would this cost to my company, you can look it up, apply your own math, and come up with a reasonable price instead of this is out of range for any organization in my country or for this exchange rate. So I went through the slides quickly, and I would like to give the Q&A back to some of the people that have managed to stay on board in this.
Marco, thanks very much. I'm sure there are lots of questions. Guys, if you'd like to put up your hand so we can just sort of control the questions, and if there's nobody, then we can just start talking.
Yes, we can.
You meant, I'll go. I'll jump in. Marco,
Sure,
you
Mark.
mentioned that you talked to Dama. Have you gone to the form and filled in specifically what you want to see in the next version? Like, have you done?
Yes.
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 Okay.
Yes. This quest came out, even before Dembok 2 came out. I was trying to get in contact with the right people to see what could be done, because there was a rumor there fact-oriented modeling was mentioned, and I'm like, okay, because a lot of organizations rely heavily on what they do adopt and what not.
Yes.
Based on what's in Dembok as a standard.
Yeah.
Yes.
So I was very pleased to see now all these decades of hard work, fact-oriented modeling made it to Dembok. But I never got hold of who was the author, and that's rather mystical. So I am in the process. I submitted my proposal and I got some confirmation. So I'm hoping that the circus will lean my way in this topic a little.
Well, you know that Deborah Henderson was the lead editor, if you will. Like, she was herding the cats.
Yeah, but there are so many people involved. It's
no. The thing was, there's tens of thousands of hours of work in there, and there's other. I've submitted half a dozen bug reports about the DMBOK. I'm curious. I can do this offline. I don't want to tie up everybody here, but I'm curious to see what you have written to Dama, what you would like the definitions to be, and what the correct text is, because we're actually doing a study group here, and it's nice to. One of the study group things, did you find the type, did you find the typo in chapter 2 kind of thing, right? Because that makes them read harder.
Yep.
Anyway, we can do this. I can.
Yes. Let's have a chat about that, because I would love to get more involved, and it's all slipping through my fingers, I feel like. So yeah. If anybody's interested in what is really a big use case out there, is that see, the question comes in. Do you know? Yes, it was not in this slideshow. I have another slide deck somewhere that shows how the Dutch Railways implemented it in their organization. And they started doing this approach and method long time ago, even before I started getting involved in this. And one of their most recent successes is that they have a ton of people, thousands of systems that need to work together. And one of the problems that they had was that if there's a disturbance on the rail infrastructure, it took them about 4 hours before they could send in a maintenance team. Because there was so much communication going on between departments, and systems needed to be checked and all of that. And through the methodology of fact-oriented modeling, they managed to build an information architecture that allowed them to finally integrate all these different departments and system identifiers. And early this year, they went with a new system in production that integrated all of that. And if there's now a disturbance on the infrastructure, it takes them 30 seconds.
Sure.
They can, it's kind of like Google Maps. They can zoom in on the map. They can draw a little circle around the area where the incident is. And the integrated information structure says, okay, then I need to take this system offline. These tracks need to be changed. This light needs to go red. This staff member needs to be notified to come back into service because we need to run another train. And these electricity lines need to go off so that the maintenance crew, which is such and such, can go into, and all of that. And they would not have been able to manage that with any other technology out there. Interestingly enough, that is all real production data, as you will. It has nothing to do with business intelligence yet. And so once they pulled this off, different departments amongst, the data warehouse teams that use Data Vault are now starting to get interested. So the cooperation with assembler modeling and trying to figure out how the Data Vault migration or model-to-model transformation should work is a timely effort, because the organization, our biggest clients, is currently very interested in hooking up to this. I hope that answers your question, Stefan. Okay, do you need to steer the conversation to elicit the facts slightly different if you're interested in the 2B? Interesting. Yeah, good question. So because again, I'm reflecting on what happens in the railways here, is that because they've been using it so long, they also have a ton of information models that are not modeled according to what do we want it to be. They basically model what they had at this point. And then they realized we need to integrate all of that. So they have modelings efforts done with domain experts on how do you use your data today. And they also have done sessions with business users across departments. Okay, how do you guys want to work together? How would that data be communicated if you all would agree? So it can provide service for different audiences, different visions or different goals, but the questions and the interviews are almost identical. You always ask, can you give me an example? And what if you would be on the phone verbally with your colleague? How would you communicate those data values? And that's basically, in a nutshell, what you're trying to extract from these experts. So no, it's not really that different. Of course, it requires a different scope. You're welcome, Johnny.
Yeah, Mark, if I could, I was fascinating there because you're terming it fact-oriented, but the DMBOK and then are referring it to the fully communication. And I'm assuming you've used the terms fact-oriented in terms of how you elicit those statements from the business in terms of give us the facts as you operate at the moment.
Yeah.
Whereas that's where Connie's question comes in is, what is fact now and down the road? It doesn't change the underlying FCO model. It's really just the definition of what is a fact. Is it what is happening today, or is the way we want it in the future? Is that a correct interpretation of what you've just said?
Well, to clarify, I'm using fact-oriented modeling because that's just, it's kind of the umbrella. It's been around so long that there have been developments on different dialects. You have the object role modeling in the US by Terry Halpin. There's a compatible tooling from Australia, Factil. In the Netherlands, we have NIAM and FCOM. So the demonstration I did was FCOM because they all have their strongholds, and the FCOM dialect, if you will, the member of this family, fact-oriented modeling family, is heavily focused on the communication parts. They all come from the same background, but the FCOM is more focused on capturing the natural language with the concrete examples, more so than the other methods.
Right.
And I can state facts on data that I have at hand, but I can also state facts on how I want to communicate about data in the future. So the verbalizations and the strategy how to elicit those is not much different. But it is different if you look at different fact-oriented modeling methods. Yes.
Yeah. And I think that was how you opened up. It's about if two people agree on that's the way it's currently working, then that becomes a fact. So that
Right.
was almost your context on your definition of the term fact.
Yes. Yeah, and that can be anything. A lot of tool extensions that we do for KStock itself is that we model that with the FCOM. So what we're basically doing is we're using facts on meta models.
Right.
There is a table called customer. Okay, those are still facts. It's just an entirely different language domain that we're verbalizing. And that shows how powerful it can be, because as soon as you can actually put it in words, you've done it.
Yeah. So if I could bring you back to what I think you're on slide 9 and 10.
Okay,
and
sure.
You made the comment about UML diagrams.
Right.
And that's something that I've wondered a lot about, and when we talk to business people, or when you go and visit them, a lot of the times you can see business process diagrams or BPMN diagrams
Right.
on their walls and things like that, but you very rarely see a UML diagram.
Yeah.
And it's been an interesting challenge for me, because when we develop, what a lot of times I get is people really buy into it when that picture is saying those 1,000 words, and it's easier for them to introduce the topic with the picture.
Right.
And very rarely do you see them come in with a UML diagram or whatever that may be.
Yeah.
Now, so what enables them to pick up a business process diagram better than and I like the way you generated different visualizations. So you could go to a concept map, which some people are now arguing it's very readable and understandable by business and people because it's about the concepts. And you're able now to almost generate whichever diagram makes sense to your audience.
Right.
Or almost and whether it's a knowledge graph or an ontology or a taxonomy, you're able to now to translate these facts into the appropriate visualization depending on your audience.
Right. Yeah, and I always it's when I do my trainings is that sometimes I show them this relational diagram.
Yeah.
And a lot of people can read that in the audience because they're technically schooled and they've seen it before. And then I point out there are 7 mistakes in there.
Yeah.
Never has it happened that anyone can find 7 mistakes. Mark, you're on mute. I wanted to say something.
Yeah, I know. I'm looking for the mistakes now. I'm a big bug hunter.
No, well, they're not in here. Sorry, the wrong diagram. But the thing is, with any picture, is that we tend to look at it and stop asking questions. And that is a problem.
That's amazing, because I find something quite different when and I've had this experience on several occasions when I use a business glossary and we do it all in Excel and there's one line and definitions, then I get very little interaction.
Right.
When I bring it into a data model, people say, no, but that's not the relationship between these different terms. So I tend to find that the picture is giving me more communication, more discussion.
Right, you're right. And I would present this one.
But yeah.
And because it has both.
I like your examples of the facts that people can see. This is where you got these associations and relationships. You got them from the facts.
Right, and even when the business users see these hanging on the wall, they can read it.
Yes.
I don't have to explain it, because that's the difficulty. Is as an ITer, I can be fluent in logical diagrams and all good, but I'm making an interpretation of what's in the domain expert's head.
Yeah, yeah.
And I'm assuming that he told me everything.
Correct.
And they never do.
And they never do. Nobody
They
does. Nobody does. You know, we if you're an experienced professional, a lot of what you can and know and do is already subconscious. And you can figure that one out by talking to 12-year-olds and explaining what you do for a living. Where do you start?
Yeah.
Now try to explain all the intricacies of your job to someone who has no training in your job, because that's what's happening. You know, if I talk to a brain surgeon as an IT specialist, you know, we're not going to meet. I have to learn the language of the domain expert, not the other way around. So I can hang up this relational diagram in front of him and he will go, yeah, I got a surgery to do, you know. But as soon as I hang this up and I have the statements in there and the communication that he gave to me, he's probably going to sign it off and says, go ahead. And that is the kind of commitment. It's no longer IT on our island with our own diagrams that we all understand, trying to build something for the business that is trusting us to do the right thing. And there's your communication gap right there.
And is that the reason for calling it that fully communicated object
Yes.
oriented? Is that's
Yes.
the core difference between that and relational and
Yes, it focuses on the communication parts of the domain expert, so that let them do the talking. And of course it needs to be, you know, stated in elementary facts. So there are a little bit of requirements there on how to write that down, but make it as concrete as possible. Let them do the talking, because they need to give that information. And if that expression is not clear, you keep talking.
And Marco, how would you handle, because lots of it these days are about having these JAD sessions, and people are almost using sticky pads to build that model whilst you're talking. Your one seems a little bit harder because it's.
Yes.
I'm not talking about this, I'm talking about the other ones where you're drilling down into the language. That sort of seems that may be problematic with a JAD type of session.
When it comes down to you know, I have this data sheet, and it has lots of similar values, and there's no purpose in going through all of that. So there's always a level of where do you apply it, and you know, like I said, this is not a magic potion. And it helps to do whiteboarding and top-down scoping.
Yes.
But that will only bring you so far. There is a point in that discovery where you need to be a little bit more concrete than just a whiteboard.
Yeah.
And
you got to get the rules out.
Yeah, that's the area where it gets complicated. This is where this is what it's really about. The rest was easy.
Right.
And you know, if you're running trains or flying airplanes and you want the cargo to arrive in the right airport at the right time, and the staff needs to be there and the passenger needs to be there, then it needs to be accurate. The experts that work with the data, provide you with the data and insight, they need to sign it off. And that's sadly it's not going to happen on a logical diagram. They will, but they won't understand.
Yeah. And how many, I mean, typically, are you almost producing a fact expression that has to deal with the relationships and associations? So how many would you expect in, I mean, because I see here, for example, an employee, Lisa reports to supervisor Ronald, and that describes that relationship. Person name reports to supervisor, that also describes the relationship. But it's not describing, I don't see descriptors of the anything else other than the ones coming into it.
Right. Well, this diagram is also a little, we're constantly evolving. The relationships came from the expression structure
Right.
and the reuse of part of these expressions, which then leads to, okay, wait a minute, I can split these structures into two, which will form then two tables, but I need to maintain the overlap, which will then form the relationships.
And that's sort of when we deal with entity relationship modeling, we're always cautious of reading forwards and backwards as to make sense of that relationship.
Well, that's the interesting part as well, is because if you look at the terminology that's being added in two directions on relationships, they are usually expressing a dynamic part of the data. Customer buys product.
Yeah,
Product is bought by customer.
The verb, the action side.
Right. Right. So, why is that in a static data structure? It's more business process than it is structure. And
that's probably the problem, because you don't have a temporal view of, or you don't have there's limitations of these relationship diagrams that we can't express.
Right. So yeah, I'm sorry to say that I can make that work in fact-oriented modeling, because you don't model it, you annotate it.
Yeah. You're talking about it, yeah.
And it is of no problem. You can make a statement that says Lisa reports to supervisor Ronald, and then simply annotate this happens in time.
Okay, but then does that mean that you may lose when you generate to the different structures, that you may lose information, similar to what happens when you go from an ontology to entity relationship diagram? You can't express everything in the ER diagram that's appropriate in an ontology.
True. There's more knowledge in an information model than there is in any technical diagram. There is.
Yeah.
But it also shows that if we do technical diagramming, we're skipping parts.
Yeah. We're not getting the whole story.
And that's where you need to have a separate document on how to properly read and use this data model. So this is all, to me, this is a very interesting phenomena.
Yeah.
And from a fact-oriented modeling perspective, I'm trying to build these bridges to how to close the gap between business and IT, and diagramming doesn't cut it. But you have very specific questions. Maybe you want to do another session sometime.
Yeah, we'd love to. And I suppose what I'd like to ask you is you're training people. What sort of coverage is this seen in the world? How many people are getting it, understanding what it is all about? And then I suppose it's a bit of a crime that all we see is that one simple diagram in the DMBOK where it doesn't even have the communication part of it.
Right. I know it hurts. It hurts, but there's so many factors in play. And I've been around for a while, so as have you. And I always look at, okay, there's this new solution coming, new technology, and I'm always interested in, why did it evolve? What problem is it trying to solve? And if you look at UML class diagrams, is that okay? There was a need to graphically design how the architecture of the software code should be.
Yeah.
But it didn't. It tapped into the problems of software development. It didn't tap into how do we do data structuring in software.
And that was what the Friday session on the knowledge gap was all about. As most of it was that appropriate communication and definitions, and we certainly did. We missed this part of it. I think you mentioned it once or twice. when they said the problem with the UML communication, and I noticed comments from yourself on that.
Yeah, it serves an audience,
Yeah.
which is in need of a solution, and that, so much is clear. And nowadays there is the domain-driven design trend in software development.
From Martin Tyler.
And it's intriguing. It's like, okay, they're trying to get back to concepts. Let's work with concepts.
Yeah.
And then if you dig a little deeper, they don't have any methodology right there. Okay, where does it come from? Well, we use domain-driven language, and it uses the domain model. But where's the domain model come from?
Yeah.
So it still doesn't solve what fact-oriented modeling is trying to provide a function for. Is that it allows you to use the tools to actually communicate with a domain expert, who not only creates the data, is using the data, knows the data.
Yeah.
And that is lacking in so many areas in IT nowadays, and AI is adding to it.
It's nice because you've got the subject, predicate, object, which is what your knowledge graph is all about.
Yes.
So you're moving into allowing us to define the structures within the knowledge graph, or the metadata that helps build or ingest that and understand the data.
Yep.
Fantastic. Thank you very much for sharing. It was very enlightening. I don't know if anybody else has questions. If you'd certainly like to have a further session on it, that would be fantastic. I'd really enjoy that.
Yeah, let's do Dutch Rail next time.
You're interested to see some Dutch Rail, yeah.
Well, I like trains.